Howdy again, it's Mr. Pete, your YouTube shop teacher. Winter is over and I'm back to making video demonstrations on the Clausing Horz Mill. So today I'm going to cut a square keyway in a 1-inch shaft. So let's get started. Just a little terminology here before we get started. This is the key, it's a square 1/4-inch key. This is the keyway in a pulley. Could be a sprocket or some other device, but that's the keyway. And technically this is the key seat, not a keyway, although I may refer to it as a keyway as well. I'm going to use this 1/4-inch wide, 3-inch diameter cutter for cutting the keyway, key seat, and I'm going to run that at about 125 RPM. I was going to use this, in fact I did cut one, but it is so incredibly dull it was nothing but problems, and this one is rather dull as well, but that is the only other one that I have, and you will see some movement and vibration, but we're just going to have to suffer with that. And the feed rate is 0.44 inches per minute. I'm going to hold the shaft in the Kurt Vise, but it could be held in V-blocks. Some people cut them directly held into the T-slots like this. Often the clamps are in the way, especially on a shorter one, so I'm going to use the vise. This key seat will be 1.5 inches long. Now when you cut your key seat on a horizontal mill, be sure and allow for the end of the cut here, which is a bit tapered, as you can see, as opposed to what you might do on a vertical mill. So the work will be held right in there. Now it could be on parallels if we needed it up higher, but it's going to be just fine in that position, so I will tighten down the vise real well. And I have already taken the time off camera to indicate the vise using this little stir-it back plunger, and I had this fastened directly onto the cutter, and I'm within 1/1000th in regards to being perfectly parallel with the axis of the machine. I didn't talk about mounting the cutter on the Arbor, but it's a 1-inch Arbor and it's a cutter with a 1-inch bore. So that's already done, and it's keyed to the Arbor, so it's not going to slip. Now there's only 2 dimensions that we're concerned with now. One, we have to find the center of the shaft by doing the touch off, and then since this is a 1-inch diameter shaft and a 1/4-inch wide cutter, the set over, once I touch off, will be 0.625, that is 5/8 of an inch. The depth of the key seat, and I found that in a book, or you can use a formula, but the depth is going to be 0.142. Now what I need to do with this cutter, but I'm holding another cutter as an example here, is to touch off on the side, that is, touch the side of the work, then raise up, or I should say lower the work, and move over what I told you was the set over. And then I do not want to cut with this much material hanging out. I want to move it all the way up like that for my cut. So I can do it one of 2 ways. One, by touching off and then moving the work in, or you can do it by another method, and I like to wrap tape, and I'm going to use this ugly green tape for this purpose, but another way would be to put a piece of waste stock like this in the vise, like that, and touch off on the side, but you'd have to do it on the back side rather than the front side, and that would find the edge of the vise, which is also the edge of the work. I'm just showing you different ways of doing it. Again, what I'm doing here is touching off, and I like to use tape, which I know that's a couple thousandths thick. You can mic that if you want to get that fine, but you can also use a piece of paper or cardstock or whatever. I'm going to run the cutter when I do that. You probably can do it without the cutter being on. So, you know, take your choice. Remember that this machine I consider a lot more dangerous than a vertical mill. The cutter, when revolving, could grab your sleeve or just about anything else that's near. Keep the rags off of the table, wear your glasses, and work safely. I'm going to turn the machine on and move in the Y direction until I just barely scrape the tape. I have to get in there with a flashlight and get real close to see that. I may speed this up. Okay, now I am touching. Okay, with the machine turned off, I'm going to drop the table. And can you see that the tape is torn? And there's really no mark on the work, but it's okay if there is a little bit of a mark. And again, I will drop the table again so I clear the work, zero out the y-axis, which I've already done, and I'm going to move over 625 thousandths. That will bring me to the center of the work. 0.625. 1, 2, 3, 4, 5, 6 and 25 thousandths. I like to count out loud, and then I will lock the table. I'm on the center of the work now, so I will loosen up the work and bring it in. Remember, there's a lot of different ways of doing this. I'm not saying this is the only way, but it's a good way, and it's the way I do it. I left the tape on there because now I'm ready to touch off to the tape as far as the depth is concerned, and then remember that the depth is 142 thousandths, or I should just say 142 thousandths. And I'm going to take it in 2 passes. Why? Because the cutter is dull. I'm quite close to the work right now, so I'll turn the machine on and raise the table until I see that the tape is being torn or cut. And there it is. I'm not sure if you can see it. From this side, perhaps you can see that I have scratched the tape. So I consider that zero. I have zeroed out the z-axis, and I will raise it 100 thousandths. Now that 142 thousandths, how did I find that? I found that in a book, which I will show you at the end of the video for those that are interested, or you can find that by formulas or whatever. But it is not necessarily just 1/2 the thickness of the key that you're going to use. There's another factor involved in there, which I don't want to talk about yet at this moment. But I will raise the table 100 thousandths and take our first cut. And now for the second pass, I will raise the table up, the final depth, which is an additional 42 thousandths. I might point out that on the Clausing Mill, 1 revolution of the knee crank is only 50 thousandths. Usually it's 100 thousandths, like on a Bridgeport. Several notes of caution here. You notice that I was brushing the chips, and you're saying that's dangerous. Well, it certainly would be dangerous if you did it on the other end, but the way I'm doing it with the cutter rotation tends to throw the brush away. But if you don't like that and you're not comfortable, don't use that method. Similarly, I was putting the oil on the top in the direction of the rotation so that the oil brush would not get caught. It'll scare the heck out of you when that happens to you. As you can see, it took a lot longer to make the setup than what it did to make the actual cut, and that could be cut in one pass probably. The cutter wasn't quite as dull as I anticipated. Now, if you were going to make a whole bunch of them the same size, this setup would be repeatable just by switching or changing the work in the vise. But if you change the diameter of the stock, you'd have to touch off and recalculate that again. Let's take it out. Now there will be considerable burrs here, so I'll file those off until the pulley goes over there, and we're going to check the depth to see if it's okay. Looks pretty good. Alright, the key seat has been deburred. The 1-inch pulley goes on freely, but will the key fit? 1/4-inch key, I said. And it goes right in. Probably should have cut it a little bit longer, but for purposes of demonstration, it couldn't matter less. So you can see how important it is to find the true center of the work and the depth. Well, there's a specification on the depth, so let's check that out. Now, in the wonderful little black book, there are several pages of data and information about keyways, both metric and imperial, but looking at this picture now, the dimension that we're interested in here is Y. So with the key in place into the shaft, the distance there from the arrow to the arrow there, and looking now on the chart for a 1-inch shaft, where is it here? There we go. For the 1-inch shaft should be 1.109, just a little bit over, almost 110. Let's see what I truly have cut. Now there's a tolerance for that, so you can be a few thousandths above or below, and it's just going to be fine as long as the key goes in. But if you go too deep, there's the possibility of shearing something under heavy load. By the way, all of this related information is free of charge. This video is really over, so you don't have to watch this. But we don't check the depth of the keyway like this. That's not the correct way to do that. The correct way is to put a key into the keyway and then measure, as I just showed you in the little black book, where my fingers are pinching. So let's put the Starrett 2-inch digital mic on there and see what I have. So what do we got? Oh, there's a glare, isn't there? Okay, I'm 1.110 almost, just a little bit over. There's the glare is gone. So I'm really within 1,000th or 1,000th and a half of what it should be. So, that's really just perfect. So that's the proof right there with the micrometer. And then, of course, the pulley or sprocket is going to go right on. Like so. Now, this is related also. One disadvantage of a square key is that it could conceivably work its way loose, whereas a Woodruff key cannot come out. And the set over, again, was 0.625. And how did I find that? The radius of the shaft and half the thickness of the cutter. Again, the depth is not half of the key, because we have this little dimension here, X, to deal with, which you can look up, and it is 16,000th. I think it's called the Chordal Depth. And there are formulas for that, but when you add that 16 thousandths onto half of the thickness of the key, you end up with 141. Well, I said 142, I think is what it was in the book. But that is how it is found. So even after touching off, so what some machinists do is they'll take a cut until they arrive at the full width of their cutter. And that would be 16 thousandths or thereabout. And from at that point, they go ahead and feed in half of the thickness of the key. Then you don't have to look anything up. But this little book has everything you need. It also tells on one of the pages what size key you should use for whatever your shaft size is. Well, that concludes this video on cutting a key seat or keyway on the horizontal mill. Remember, that applies to any horizontal mill, not just a Clausing. Now, there'll be several more videos in this series on cutting key seats, keyways, so watch for them. And be sure and practice the golden rule. This is tublcain saying so long for now, and I'll see you in my next video.